for a little while. I've been helping out my students quite a bit with their revision, but I'm here again to introduce a new series. This is a new series for those of you that are in the last few weeks of revision. It's called The Final Three, and what I'll be doing is going through the last three questions of each exam paper. I'm probably going to try and do all of them if I can, that have been in existence since 2017, starting with the paper I'm going to do today. So the paper I'll do today is June 2017 at Excel. I will link the paper on the comments section below. If you could leave a like and subscribe, that would help me out a ton. And if you want to keep an eye out in the next few days and weeks, I'll be adding a few of these videos, so this will hopefully help you in your revision. Right, without further ado, let's have a look at question 20 from paper 1, June 2017. That's the non-calculator paper. And so you can see here, this is a simultaneous equation problem. And you've got to spot it, first of all, that it's a non-linear. So we've got some square terms here. And so that's a non-linear simultaneous equation system. You'll have two types of simultaneous equation problem that you'll be able to do. One is simple linear simultaneous equations, which you do by elimination, so you'd have learned that. And then there's this type, which is a non-linear simultaneous equations. How you solve these is by substitution. So we're going to start off by looking at this second equation here, and we're going to try and make a substitution, make it as easy as we can. And you can see that this equation says y minus 3x equals 13. So we can simply rearrange that to give me the idea that y is 13 plus 3x. I'm going to try and write the 3x first, just because that will help me a little bit later on. So y being 3x plus 13 is a nicer way of writing it from the point of view of what I'm about to do. So then back in the first equation now, I'm going to rewrite x squared plus, but instead of y squared, I'm going to put this, this thing squared, so 3x plus 13 all squared, and that's equal to 25. Now we've got to multiply out these brackets, so we'll do that real quick, and if you do that correctly, you'll get 9x squared, and then 13 threes are going to be 39, two lots of that is 78x, and then 13 times 13, 169. And then rearrange this all together, collect it all together, you'll get 10x squared plus 78x, and then 144 equals to 0. So I'm collecting all the numbers together and all the letters together. Now this here is, everything here is a multiple of 2, so I'm going to divide everything by 2. So I'm going to get 5x squared plus 39x plus 72 equals to 0. And then this is non-calculator paper, so we can't solve by factorising. We can't solve by using a formula, so we're going to solve this by factorising. So in case you're not sure about how to factorise this, it's got a coefficient of x squared, so your teacher might have taught you to multiply the first term and the last term together, so 5 lots of 72. Now 5 lots of 72 is 360, and I'm looking for factors of 360 that add up to 39. Now I'm pretty good at my factors. I know that 10 lots of 36 makes 360, but that's not going to make 39. I know that 20 lots of 18 is going to make 360, but that doesn't give you 39. And you can see that that's 46 and this is 38. So it must mean that my factors are somewhere in between these numbers. So 15 and 24, halfway between these two, 15 and 24 add up to make 39, and 15 lots of 24 do make 360. So you can pick the factors out quite quickly from what you know if you just go through it and have a look and try things out. So these are the two factors. Then what you're going to do is pair these factors off. So we're going to write the first term exactly as it is, 5x squared. And then I'm going to write 15x here because I know that 15x and 5x squared are related. And then I'm going to write 24x and 72, and again I know that those two are related. I'm going to take out what's common from the first pair of factors here, so 5x, and I'm going to get x plus 3, and then I'm going to take out 24, and then again I also get x plus 3, and so my factor pairs are 5x plus 24 and then x plus 3 equals to 0. It's quite a lot of work, this question. We're going to get the answers x equals minus 24 over 5 or minus 3 by letting these two equal to 0. Now this question happens to be worth 5 marks, And some of the marks will be got by doing the x coordinates, but don't forget you've also got to get the y coordinates. So going back up to the beginning, we know that y is 3x plus 13. So by substituting these values in, we're going to get the corresponding y values. And if you do that carefully, well, this one's the easiest one to do. So minus 3 times 3 is minus 9. Minus 9 plus 13 is 4. That's quite easy to do. And this one, well, I know that 3 lots of minus 24 is minus 72. So minus 72 over 5 would be the corresponding y coordinate. And that hopefully will get you your 5 marks. So these two go together and these two go together. You will just try and experiment. It is worth trying to experiment just at the end to make sure these work. So if I take minus 3 and 4, for example, minus 3 squared, back up in the question again, minus 3 squared is 9, and then 4 squared, take 4 there, 4 squared is 16, and 9 plus 16 does make 25. So I know that these work. So this is one area of maths I do enjoy because you can check that your answer is indeed the answer. Okay, moving on. The second last question in June 2017 was this one. So it's a quadrilateral trapezium. They're telling you some things in the question. They're telling you that this is the same as that, and they're telling you that this is the same as that, and they're saying prove that AC equals BD. Now the first step is to draw that line in. So I'm going to take a ruler and draw that line in. So this is AC, okay, roughly, and then this is BD, okay, and what you're forming here is two non-right angled triangles. So we're starting to think, how can I prove that things are the same with triangles? Well, this must be a question to do with congruence. Now, if you look at the triangle BCD, we can see that this angle in here is definitely going to be the same as this angle in here for the triangle ABC. So I'm going to tell the examiner that. I'm going to say, look, the angle ABC is the same as the angle BCD. We're told that in the question. We're also told that AB equals CD, so that's important. So we've got two of the sides in each triangle, so this side in this triangle here, and that side in that triangle there, they're both identical. And we know this is shared, so BC is shared, so that has to be the same for both triangles. So they've got one side in common and two sides in common, and then an angle in between. So you've got side, angle, side, side, angle, side, and then again, side, angle, side. So because of side, angle, side, we've got congruence. That's one of the conditions for congruence. And so if we know they're congruent triangles, that must prove that AC equals BD. And that's a very nice, easy set of questions that gets you the answer very quickly. And that is worth 4 marks, which is quite a lot of marks for a question of this type. So do revise your congruence properties and do make sure you know what makes triangles congruent. The last question in this particular paper was quite a hard one. That's this one here. So I hope you can see that in the question. I'll scroll up for you so you can see it in a second. So this is showing a hexagon. So 1, 2, 3, 4, 5, 6. It's telling you some things. It's telling you that there's some congruent parallelograms in there, and that this AB is BC is X. So I'm going to just draw that in there. So this is X here. It's saying P is a point on AF, so there's P, and Q is a point on CD, such that BP and BQ are both the same. They're both 10. So again, with my ruler there, I'm going to join those points in just to show where those 10 centimetre lines are. So I'm going to do that real quick. Okay, I'm going to write that in there. It's 10, 10, just to help me out there a little bit. And then the last part says, given that ABC is 30, so this angle across the whole of this is 30, we've got to prove this horrible expression, PBQ equals 1 minus blah, 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 x squared. Right. Before I get to this, I'm going to start looking at what I've got. Now, it would be helpful from my point of view to start looking at different triangular systems. So the first thing I'm going to start look at, because we know this is going to be a triangle question, because this is cos and this is talking about angles. So I'm thinking it must be something to do with triangles. That's the only thing I know in GCSE Maths that involves angles and cos together. So it's got to be something to do with triangles. Now I'm going to construct here two different triangular systems. I'm going to construct the system ABC, so I'm just going to sketch that up here. So this is ABC. And what are we told about ABC? Well, we know that's x, we know that's x, and from the question I know that's 30, because we were told that earlier. Just a reminder, there's the reminder from earlier, that's 30. I know from this diagram here that the distance between A and C is the same as the distance between P and Q, and that's really helpful for later on. I'm going to start off by giving me an expression for AC. Now I've got side angle side, so it's a bit similar to the previous question, except we are doing triangles here, non-right angle triangles, so it must be to do with cosine rule, side angle side, missing side. So I'm going to do AC squared equals x squared plus x squared minus 2 lots of x times x times cos 30. Okay, that's just the variation on the cosine rule that we're going to use. So this is quite simple to do, so 2x squared, and then we've got 2x squared, and this cos 30 is root 3 over 2. And if you don't know those values, you should try and learn them because they're important, particularly for non-calculated paper. Now, AC squared then, if we look at what these two things have got in common, well, firstly, 2x squared times root 3 over 2, we can do something with, so we're going to do that. So this is going to be root 3x squared. When I do it, because the two twos going to cancel each other out, and then I'm going to take out what's common, so I've got x squared here, so I've got 2 minus root 3. Okay, so AC squared equals x squared 2 minus root 3. Now I could square root it, but I know I'm going to need it in this form later on, so if you really wanted to, you could write down what this AC is. It's the square root of all this stuff, but to be honest, you're going to be squaring it up again in a minute, so I'll refer you to this in a second, but just in case you wanted to, you could write that down. Now that's the first triangle we've dealt with. There's a second triangle here that we haven't touched yet, which is PBQ, and that's relevant because we're asked about the angle in the corner at PBQ. So I'm now going to draw my second triangle that I've got, my second right angle triangle, PBQ. Now we're trying to work out what this theta is here, this PBQ, this angle is the one that they want. And we're told some things. We're told that's 10 and that's 10. And we know what PQ is because we've just worked it out. PQ is this expression here that we're going to do. So I can work backwards to give me my angle, hopefully. That's the theory and strategy we're going to use. Just going to wait 1 second. Right, that's the theory and strategy we're going to use. So we know that PQ squared equals 10 squared plus 10 squared minus 2 lots of 10 times cos of PBQ. This is the one we want for later on. 10 squared is 100, and then again 100. I've got 200 here, and then cos PBQ. PQ squared from earlier, just a reminder, that's this. Okay, so we're going to write that down now. X squared 2 minus root 3 equals, and then we're going to have 200 and minus 200 cos PBQ. Now again, I'm going to take out what's common here. So I've got 200 in common. 1 minus cos PBQ. So just taking out what's common. I'm going to divide by 200 on both sides. So I'm going to squeeze that in real quick. And that's going to be 1 minus cos PBQ. And then I want cos PBQ on its own. So I'm going to take the cos PBQ over. I'm going to minus this stuff away. So by simple rearrangement, we are going to get the form that we need. So I'm running out of space a little bit, but I'm going to try and squeeze it in here. So you'll see really fast that you are going to get the form that you needed in the question. 2 root 3 x squared over 200. And that is a very simple rearrangement of the formula. And that is exactly what we were looking for. The 1 minus 2 minus root 3 x squared over 200. And that concludes this particular final 3. Keep an eye on the channel for the next few days because I'm going to be putting a few of these up. Keep an eye on the next few weeks as well. I'll be doing a few of these. Each paper from June 2017 I'm going to do. As I mentioned earlier, I will add the paper in the comment section below. So my thanks to Edexcel and Maths Genie because I'm going to use those two websites to refer to. So do take a look at those links and make sure that you've got these questions covered off. Good luck in your exams. I do wish you all the best and I hope you do really, really well. Hopefully, I will see you soon. Bye-bye.